So this is not a complete solution. I was able to solve only 3 subtasks, so I will just give you my approach. Maybe it will help someone. So if you're looking for the complete solution, this is not the video for you, right? So what do we have is basically we are given n heap of candies, and for each valid I, the ith of them contains I raised to power k candies, right? I start from 1 as I assume, right? So that is what you are given. So and then what you have to do is you have to partition these heaps into 2 groups, so that sum of candies in one group is as close as possible to the second group, right? For example, suppose you have these many, so suppose k is equal to 1. So first will be 1 raised to power 1, second will be 2 raised to power 1, third will be 3 raised to power 1. So now you have to distribute into 2 groups. This group will be 1 plus 2 and 3, because the difference now is 0. But if it was 1, 2, 3, 4, then again you can do it. So let's say it was 1, 2, 3, 4, 5. So now the sum is 15, and the closest you can get is if you take 3 and 4 in one group and you take 5 to 1 in one group, then one group will contain 8 and one group will contain 7, and the difference will be 1. There is one more way to distribute it. It is 5 and 2 you take and 1, 3, 4 in another group, right? So the difference is still 1, but there can be multiple ways of distributing it. So I will just tell you how I did it, because I was not able to solve the last subtask with this. So what I did was, like, the n can be till 10 raised to power 6, right? 10 raised to power n can be till 10 raised to power 6. So for k is equal to 1, the sum will actually be till 10 raised to power 12, something like that, like in that order. So what I did was I created a subset sum for initial sum values. For initial 10 raised to power 6 values, I created a subset sum. So basically this data structure will be able to tell me that if a number is less than 10 raised to power 6, can I make that number using all these powers? So for k is equal to 2, this number will be equal to 1 square plus 2 square, 3 square, something like that, right? So that is what I did. This data structure can tell me if I'm able to make that value below 10 raised to power 6. So what I did was I started from the highest number. So first I calculated the total sum. That is trivial. So I will just show you my code, because okay, so it is taking too much time to load. Well, hopefully it will load someday. So but what did I do was, let's say we are looking at 1 square plus 2 square. So it will be 1, 4, 9, 16. So suppose you have to divide this. So the sum is 30. Oh, is it 30? 16 plus 4, 20. Yeah, it is 30. So we want 15 as the half. So one group we can make 16, and 4, 9 and 1 in another group. So 16 and 14. So the difference will be 2. Let me see if we can do smaller than that. So we will look at my solution. So I don't think we can do smaller than that. Let's see if we are given a test case. It is still loading. Right. So this way. So how I did it was, I basically try to subtract. So I get this half value, which will be 15. Then I try to subtract elements starting from the last number. That can I get this number, right? So if that number is greater than this, then I will not use it. But if it was 9, then I will use it. So something like that. I keep decreasing it. So that way I just keep subtracting the numbers from top till I am able to reach a number which is in this subset sum, and then from that subset sum I will directly give an answer that number can be formed, right? So that way I can tell what will be the minimum difference, or basically in this subset sum I can tell which is the closest one, right? So hope my solution has loaded. Right, so something like that. For 1 it is very easy, because it can be proved for number from 1 to n, right? If you have number from 1 to n, you can form any number from 1 to n using the sum of these numbers, or you don't even need to have the sum, right? You can just, so basically you can form all the numbers from 1 to n into n raised to power 1 divided by 2. Right, so so basically for this subset sum is like everything is true. So that's why 1 has a different, so basically I was trying too many things, but for 1 what did I do was, like, I take half and I start picking the numbers from top. So whenever I just keep subtracting them, right? And I say this array will indicate which number I am choosing in my group, right? And the other group will be zeros. So if you know what is the output, so whenever array I will be true, I will print 1, and otherwise I'll print 0. So I keep subtracting the biggest numbers from this half, and whenever half becomes less than I, which means like I can do less than 10 to the power 6 as well, but whenever it becomes less than I, that means if you look at the iteration for 1 raised to power 1 n raised to power 1 series, then you can just see that you will always be able to make. So let me just try run this. So suppose you have 1 2 3 4 5, so the sum was 15. Okay, let's look at 21 28. Now I need to see if I can make 14, right? So what I did was I take so the sum is 28, half is 14, so I take 14, so I subtract 7, then I get 7, but 6 is still greater than 7, so I subtract 6. Oh wait, now then I get 1. Now 1 is less than 5. I just check if my subset sum contains 1. As I told that all the indices below I can be formed can make any number, right? Which is in this range, so that number will always be there. So this set itself can act as a subset sum. So that's why in that case I just return, right? So that is the thing, that whenever half becomes less than I, then basically I just use that element itself as the candidate, right? So in this case half is decrementing, right? So half was 14, then it became 7, then it became 1, and when it was less than I itself, then I know that there will be a number, then I pick this into this group. So that is for 1. What did I do for 2? And I did similar thing for 3 as well. So I created a subset sum till 10 to the power 6 or something like that. 3. So I created a subset sum till 10 to the power 6, and this subset sum will store for me. So where am I creating? Yeah, I'm creating it here, right? So this is my number which I'm adding to the subset sum. So this subset sum, maybe you can read about how you create it. So every element of subset sum will tell me how I was created. So that way, first is it will tell me that I can be created, and second it will tell how I was created, right? Then after that I did the same thing. I find half, and then I start from a number n, and then I keep decrementing it. And whenever the half become less than upper, what is upper? Upper is still what limit I have calculated the subset sum. So under that limit I can look at my subset sum data structure and tell which is the closest value. So how do I calculate the closest value? If subset sum tells that half it actually is present in subset sum, then closest is actually equal to half. Otherwise I'll look at some values ahead of it and some values below from it, and these values, how many steps to look, I found by generating the answers for the subset sum, right? So I found out what is the maximum gap for I, and then something like that, right? So you can just look below that number for some locations if you're able to find the closest number to that, and above that, right? So suppose your subset sum does not contain, let's say 11, then you go till 5 and you go till 16 and you see if any of them is present, which one of them is smaller, you just break there, and that is the closest of your number, right? So that's it. And then I have written a function which will read my subset sum data structure and tell me how I can form that closest number using this. So for example, in this case, so when I look at, for example, suppose, so my data structure will actually for this case, right, for example 1 4 9 16, because my data structure contains value till 10 to the power 6, it will already contain the value that yes, you can form this value or not. So half was 15, it can say no, I can't form half. So it will look at what is the closest value which you can form. It will find 14 and 16, and you can choose either one of them, and my subset sum data structure will give how it was formed, and from that how, so this how function will give me an array of list which will tell how you can make that closest thing, and you, for that all that list, you set array of I equals to true, and wherever the array of I is true, you just print 1, and otherwise you print 0, right? So I will just repeat my idea is that I formed a subset sum from 1 to 10 to the power 6, and I kept adding the higher range of numbers to my group, and whenever I reached below this limit, and then I just checked my subset sum that can I what is the closest number to that number which can be formed. So there are some implementation details there, but I will not talk about them because this is not a complete solution. But this did not work for enrich power 4, and for enrich power 3 I have to do minor implementation improvements, which is like I started from maximum number, but then I also had to start from second maximum number. So sometimes it was not giving the answer, so I took the minimum of both of those cases. So that's it for this question. Hope it gives you some ideas to play with. Thank you.